identities again, and this will be the last day that we spend in this section, and we'll be moving on. Okay, so first of all, if you remember, we picked the most complicated side. Most complicated side is what?
Left.
The left. Now we're going to do something that we typically haven't done before in the past. Okay? Typically, we would change everything to sine and cosine, right? But we're not going to do that now. What I'm actually going to do is I'm going to go ahead and distribute that secant to each of the terms above. Now you're probably wondering, well, why? And I'll show you shortly. Okay, but we're just going to distribute the secant to each. We're going to divide both by secant. Now, as I said, you're probably wondering, why did we do this instead of converting everything to sine and cosine? We're saving about 2 to 3 steps by doing this. And the reason is because I know that secant equals what? 1 over cosine. So let's think, what do I know that 1 over secant would be equivalent to? Cosine. And so do you see now why I chose to do that? Because by changing this to 1 over secant, I've now already gotten the first thing that it's equal to. Okay? So that was kind of one of those things. I looked at the problem and said, okay, where am I going? What do I need to do? So this is an option that you can do. So you've got cosine of alpha. And so then now what I probably would do is convert these to sine and cosine. All right? I know that cosecant is 1 over sine. And I'm going to divide that by secant, which is 1 over cosine. How do you divide 2 fractions?
Reciprocal.
You multiply by the reciprocal, so really I'm going to multiply by.
Cosine. Or just cosine.
Yep, or just cosine, doesn't matter, same thing. Okay. And now, what do you know that cosine over sine is? Cotangent. So there we go, we've proved what we've needed to prove. Now, if we would have changed everything to sine and cosine from the very beginning, we still could have gotten to this step. It might have just taken us about 2 steps longer. Okay. So far so good? We got one more we're going to look at today. We're going to add a few problems, and then we'll be done with this section. Okay?
Sure this time.
Now, I'll be honest with you. This one, I think I got to the orange color. So it's really not, I mean, it's a longer problem, but it's really, I mean, it's not one of the longest we've looked at.
So it's going to be 1 over cosine, right?
So,
Minus sine over cosine.
that's right, squared. Now, some people would think that the left or the right side would be the most complicated side. I would actually deal with the left side. Okay, and as Cole already said, I would go ahead and change secant to 1 over cosine, and I would change tangent to sine over cosine. Oh, second, put the fish. It's supposed to actually be the B. Okay? And I'm going to square that. Now, this is one problem. We haven't looked at a technique like this that we're going to get to within the problem, so it's really important that you pay attention on this one. Okay, because this one is going to be a little bit different when we get to about the middle to the end of the problem. So now, what do you notice about in the parentheses? They're both the same denominator, so that's what's really nice, because now I can write that as 1 minus sine over cosine. Now, what does it mean to square something? So I'm going to also take it times itself, because I'm going to get rid of that squared. And I'm going to show that that equals 1 minus sine over 1 plus sine. Now normally, you would probably FOIL out the 1 minus sine times the 1 minus sine. There's a big reason why I'm not going to do that. Okay, can somebody guess why I'm going to choose not to FOIL that out at this time? Notice what I have here on the right. I have a 1 minus sine, right? So by FOILing that out, I'm going to, I think, probably be messing with something that I might be able to hopefully cancel out with in the future. What's cosine times cosine? Cosine squared. So now, when I look at that problem, I now think about a song that you probably sang in elementary school. One of these things is not like the other. Okay? Remember that? One of these things is not like the other. One of these things just doesn't belong. So which one doesn't belong? Which one is the odd person out? Cosine squared. So is there a way that I could somehow get rid of cosine and write it so that it would be something like the other? 1 minus sine squared. Perfect. Exactly right. So I'm going to change cosine squared so that it's 1 minus sine squared. All right. So now I have 1 minus sine squared, or sine of beta quantity squared over. Now before I write that denominator, we're going to take a little trip back to the past. Okay? And I want you to look at this problem right here. I want you to tell me, what could I do with this problem, x squared minus 4? Is there a way that I could possibly factor that? Or is there a way I could do something with that? What would it be?
X parentheses minus 4. Or
X
X
plus
parentheses X minus 4.
And X minus 2.
Oh.
So really, what do you know about x squared and 4? They are both what? Perfect squares. And so since they're both perfect squares, I can factor by using the difference of squares. What do I know now about the 1 and the sine squared? They're both perfect squares, right? So they're the same as this x squared minus 4. And so with that in mind, I'm going to factor this denominator as two distinct quantities, just like I did with the x squared minus 4. So let's look first. What is squared to give me the 1? 1. All right? What is squared to give me the sine squared? Sine. What do you do now? Minus and a plus. Ah. And so now if you notice, what happens? The 1 minus sine here cancels with one of these. And what are you left with? 1 minus sine over 1 plus sine. But we haven't looked at that factoring the difference of squares before. And you're going to actually have to do that on today's homework. Okay. So,
Is that all of them?
what do you mean, is that all of them?
Is there only going to be like 1 or 2 like that?
I don't know for sure. I know for sure you've got 1. So now what I need you to do is add 7 problems to your homework. Here are the 7 that I need you to add. I need you to add number 10, number 16, number 20, number 21, 26, 27, and number 30. Okay? 10, 16, 20, 21, 26, 27, and 30.